Good evening, all of you.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
So, today we'll be covering three slides, three presentations will be there. The first one will be on the planet Earth, followed by the one with Mars, and later comets and asteroids. So, yesterday we studied about Mercury and Venus. Mercury was a Roman messenger to God, and Venus was the goddess of love and beauty. The third planet from Sun, our Earth. So Earth is the only planet to be named in English, and the word English is old English word for the land. We don't know who named the planet the Earth. We just know that the word means land or soil.
Miss, as in the word earth derived from Anglo-Saxon.
Yes, it is on Old English. And once again, shape of the Earth. The study of size and shape of the Earth is called geodesy. So in geodesy, we know that earlier we believed that Earth was flat, and even now also there are people who believe Earth is flat. But we know that thanks to a lot of astronomers, philosophers, from Aristotle to Pythagoras to Newton, they knew that Earth is kind of spherical. And later, it was Isaac Newton who showed that Earth was not just a perfect sphere because it is rotating on its own. Um, because why it is rotating? What happens when our body rotates? When a body rotates, when a body rotates, everybody please mute the system. Yes. So when a body rotates, the central part, I mean the equator part, that will become a little bit outside than that of the polar region. So bulging will happen in the equator part, while in the polar region it will just become a little flat. That kind of a shape is called oblate spheroid. Here you can have a look at an example of oblate spheroid. This is an exaggerated example. Earth is not having this much bulge, but sure, it has a bulge in the equator. Oblate refers to the oblong appearance, and the term spheroid means that it is almost a sphere, but not quite. Now let's have a look at Earth's formation and evolution. Scientists think Earth was formed at roughly the same time as the Sun and other planets formed about 4.6 billion years ago. We yesterday studied about the formation of Sun and planets. Yesterday and day before yesterday, it was from solar nebula. As the nebula collapsed because of its gravity, it spun really faster and flattened into a disk. That disk was called accretion disk, and most of the material was pulled towards the center to form the sun. And the remaining planetesimals.
Miss, nebular contraction and condensation.
Okay. Now, most of the material was pulled towards the center to form the sun, and other particles within the disk collided and stuck together to form ever larger bodies, including Earth. Now, Earth's formation and evolution. Scientists think that Earth started off as a waterless mass of rock. In the previous slide, we said that it was formed some 4.6 billion years ago. But now we know that when it was forming, water was not present in its surface. There are a number of theories by which we conclude how water became, a crucial element molecule on the Earth's surface. I mean, 70% of Earth's surface is covered in water. We have five oceans, right? From Pacific Ocean, Atlantic Ocean, Indian Ocean, the Southern Ocean, and Arctic Ocean. So we found that either the water should have been come from a carbonaceous asteroid, and because the components and the isotopic studies in asteroid matches with the isotopic components and contents of ocean. So that's how we got water. And due to and earlier when this water was introduced into the system, at that point it was not ready. Earth was not ready to make it in the liquid form. But later, it Earth was really hot and it melted in the Earth's interior and causing some chemicals to rise to the surface and form water, while others become the gases in the atmosphere. So there are recent evidences that suggests Earth crust and ocean may have formed within about 200 million years after the planet had taken shape. Now, we know about our Earth a bit more than any other planet in the solar system because we live on it. And since there are different processes that happen from the beginning of Earth, we can divide it into different stages to study it more you know, um, deeply. So, starting with the earliest, there are four eons. The whole history of the Earth can be divided into different eons. The first one is Hadean eon, followed by Archean, then Proterozoic, and the last eon, which is Phanerozoic. The first three eons, which together lasted nearly 4 billion years, and are together known as the Precambrian. I mean, the Hadean, Archean, and Proterozoic era eons are together known as Precambrian. It is the last eon, Phanerozoic, we talk about life. Evidence of life has been found in the Archean about 3.8 billion years ago. That's right, but life did not become abundant until the Phanerozoic. Again, the Phanerozoic is divided into three eras. So there are four eons in the history of Earth, and the last eon is Phanerozoic. Phanerozoic again is divided into three eras, starting with the earliest. These are the Paleozoic, Mesozoic, and Cenozoic era. So the life became abundant in the eon Phanerozoic. It's an important question, and it's been divided into three eras. The Paleozoic era, so the development of many kinds of animals and plants in the seas and the land. Then there was Mesozoic era. It was the age of dinosaurs. In the Cenozoic era, which is the current era, it is the age of mammals. Here you can see in the Paleozoic era, where it is divided into Precambrian, Cambrian, Ordovician, Silurian, different organisms were there. The first vertebrates were presented in the Cambrian era, and the first seed plant appeared in the Carboniferous era. And we are in the last era, the Cenozoic era, which is divided into two. The first one is origin of primates, and the quaternary one, which is the present one, humans here. Now let's talk about the age of Earth and the many of the scientists who study about Earth believe that human began to evolve 1.4 million years ago. Even fish was there 500 million years ago. So human is comparatively new to Earth. And Earth's first life form appeared some 3.5 billion years ago. Now there comes the structure and the interior components of Earth. We know that we do have a crust um, beneath which there is a mantle, and inside that we have a molten outer core, and inside the outer core we have a solid inner core. So let's have a look at how our crust looks like. Outermost layer of Earth is called the crust. It is a surface of Earth, where we are standing, where we are building home. That is called crust. It comprises the continents and ocean basins, and therefore it has been classified into continental crust and oceanic crust because there is division between continental and oceanic crust. The first one is the continental crust is thicker than that of oceanic crust. Continental crust averages some 25 miles or 40 kilometers thick, although it can be thinner or thicker at some areas. It's not like in every area it is 40 kilometers, but sometimes it is thicker, sometimes thinner. But the oceanic crust is anyway thinner than that of the continental crust. It's only about 8 kilometers thick. Here in the schematic figure, you can see the continental crust and the oceanic crust. This is the upper mantle after that. So, mantle is 2,900 kilometers thick. Earth's crust floats on the mantle much as a wood floats on water, and the slow motion of rock in the mantle shuffles continents around and causes earthquakes, volcanoes, and the formation of mountain ranges. So, the Earth crust is floating on the mantle, just like a wood floats on the water. Okay, it is actually these slow motion of continents that is called the plate tectonics. Earth has a different plates which is moving on the above this mantle. The division between the crust and the mantle, it's called Mohorovic discontinuity. Again, an important question. What is the division between the crust and the mantle is called? It's Moho discontinuity or Mohorovic discontinuity. Now the core. Earth core is about 7,100 kilometers wide. There is an outer core which is hot and liquid layer comprising mainly of nickel and iron liquid. And this is the reason why we do have magnetic field because this layer is liquid, I mean molten, I mean it's in the molten condition and it contains nickel and iron. Both have magnetic properties. They are ferromagnets. So when they move faster as the Earth is rotating, due to the relative motion, what happens? Magnetic field is produced. This effect is called dynamic effect. The transition space between outer core and mantle is called Gutenberg discontinuity. Here, it's the gap between the line between mantle and crust was called Mohorovic discontinuity, and here between outer core and mantle it's called Gutenberg discontinuity. Now we have got the inner core. Inner core mostly made of solid iron and has little amounts of nickel in it. It is believed to have the extreme temperature and pressure conditions. The transition region between outer core and inner core is called Lehmann discontinuity. Now about the orbital characteristics. Yesterday we studied about the rotational plane, right? We talked about the tilt of Earth. It is because of this tilt of Earth we do have different seasons. So Earth spins on an imaginary line. It's called the axis that runs from the North Pole to the South Pole, while also orbiting the Sun. It takes Earth 23.439 hours to complete a rotation on its own axis and roughly 365.26 days to complete an orbit around the Sun. That is 365 and 1 by 4 days. That's why every 4 years we have a leap year because this 1 by 4 counts up to 1. And so we add one more day into our calendar. Now, Earth's orbit, it's not a perfect sphere. Oh, I mean, perfect circle. It's called ellipse. Earth or and every planet revolve around the sun in elliptical orbit. Now let's have a look at some of the statistics about Earth. You don't need to, you know, by heart all these numbers, but just have a look at it. Average distance from sun is called one astronomical unit. It is 1.4 into 10 raised to 8 kilometers. Now about the perihelion, which is the closest approach to sun, it is 1.4 1.47 into 10 raised to 8 kilometer, while the aphelion is 152, that is 1.52 into 10 raised to 8 kilometers. Perihelion is the closest approach of a planet to sun in its elliptical orbit, and aphelion is the farthest point from the sun in an elliptical orbit. Now, yeah, there is an equatorial inclination to orbit, which is 23.43 degrees. And how many motions does Earth have? The first thing is rotation. Rotation of the planet around its own axis with a tilt of 23 degrees. And the Earth rotates on its own axis from west to east. Unlike Venus. Venus rotates from east to west. That's why Venus sunrise is in the west. The rotation of the Earth results in the alternation of day and night. Of course, that's common sense, right? And there is this important question. Why does Earth have seasons? Earth has seasons because its axis is tilted. Thus, the sun's rays hit different parts of the planet more directly depending on the time of the year. See, look at this map, this figure. Here, the southern hemisphere is facing the sun. There is light here, right? While the northern hemisphere, it's winter. It's summer in the southern hemisphere. So again, when it revolves and reaches the other side of the elliptical orbit, the northern part will be receiving more light than that of the southern part. Earth has seasons because its axis is tilted. Thus, the sun's rays hit different parts of the planet more directly depending on the time of the year. Actually, the summer is warmer. We know that, right? The temperature is more during summer, atmospheric temperature I'm talking about. And why is that? Because the sun's rays hit the earth at a more direct angle during summer days. So in the opposite hemisphere, it will be winter. And one more thing, when you are living in equator, you won't feel winter and summer. You won't feel that there is a drastic difference between winter and summer. For example, we live in India, right? So in the southern part of India, which is closer to the equator, the winter season is very weak. While the northern region winter season during December to February, it's affected, right? Temperature goes below 10 sometimes, below 0 sometimes. Yeah. But other than the hill stations, in Kerala and Tamil Nadu and all, we never reaches 0 degrees or even 10 degrees. So there is four seasons. The first, say from December to February mostly, that is winter. Then from March to May there is summer season, and we do have a rainy season, that is the monsoon season from June to September, and after that a post monsoon season is there.
Ma'am, can you
Now,
please go to the previous slide?
okay, this slide you mean? This is actually not part of the syllabus. That's why I skipped it.
Oh, yes, ma'am. Thank you.
Yeah. But here you can see that, see, This is a summertime. Summertime, what happens? Sun is actually directly hitting the northern hemisphere, and during autumn and see different periods of the year. Yeah, anyway. Um, before we invented clock, people used to check time using a peculiar sundial. Maybe you have, if you have been to Jantar Mandir of Delhi, you may have seen the Samrati, the biggest sundial on the world. Now we do have accurate atomic clocks. Now, yeah. Next thing I would like to discuss with you is locating places on Earth. This is a very important thing because there are different places on Earth, right? We name those places, but is that enough? What about in specific regions in the ocean? Can we name that too? No, right? Even if there is no distinguishing features, we cannot distinguish between different regions. So, what makes that possible to locate places on Earth? We have drawn lines over Earth, the parallel lines of the equator, the lines which are parallel to equator, the horizontal lines. They are called latitudes, and their vertical lines, which is perpendicular to the equator or latitudes, which runs from north pole to south pole. They are called longitude. So, with specific longitude and latitude, that is actually unique. If you are living in in an area, you will have a lat and long, and that lat long cannot be for any other place. That's how we can manage um, mapping any region on Earth. Now, we do study Earth by different means. For example, we do sample soil and we do study radio measurements, etc. But when we are in space era, we can study Earth from space. There are different Earth observing satellites. Even ISRO has some. MEXAT is an example of that. And to study and to navigate, to enable communication system over the world, satellites are there. It remote sense the different data sets. Remote sensing means observing something without touching, without physical touch. So this method, either they will retrieve the light coming back from the surface, or they will send a signal and take back that signal. In that way, they'll get enough data about different things. For example, mm, ocean, studying about ocean and satellite oceanography is very important. In my research areas, we do that a lot. We study about the surface of sea temperature and then yeah, salinity, then how much chlorophyll is there, and sea level, height, etc. So it's very important to study Earth from space. Many countries, many space organizations have different satellites orbiting Earth. And you know that there are different types of satellites. For example, geostationary satellite, polar satellite. Geostationary means which revolve around Earth parallel to the equator, some 36,000 kilometers altitude. And the peculiarity of that is it revolves around Earth and its period is 24 hours, which means it will be looking at a single, if the satellite is above the earth, as earth moves, the satellite moves along with it. Earth takes 24 hours to rotate on its own axis, and similarly the Satellite will also take exactly the same amount of time. So it will be looking at India itself. That kind of satellites are called geostationary satellites. Satellites which run from pole to pole, they are called polar satellites. Now, there are some amazing facts about the planet. Let's have a look at it. So, Earth was originally born as a twin to the planet Theia. You may have heard this collision theory how our moon is formed, which was about half as wide as Earth and roughly the size of Mars. The two planets shared an orbit for several million years until they collided. Earth absorbed Theia, and the remaining debris eventually coagulated into Earth's moon. And the mass donated by Theia. It is the mass donated by Theia which gave Earth the gravity necessary to sustain a sustainable atmosphere. If that was not happen, maybe we won't be sharing our knowledge now. Hmm. Now, the world's largest desert, it's the Sahara, and it covers about one third of Africa. Now, the longest river is Nile, stretching a length of 6,696 kilometers, which is the largest river.
Nile.
No, Nile is the longest river. Largest river is Amazon. Yeah, which is the highest waterfall.
Niagara. No. Angel
Niagara?
Falls.
Angel.
Niagara Falls?
It
Angel
is
Falls.
Angel Falls.
I said Niagara at first and then I switched to Angel.
Okay, that's fine. Now, Mount Everest is the highest mountain on Earth. Its peak reaches 8,848 meters above sea level. Now, the hottest place on Earth. This fiery award for Earth's hottest spot goes to El Azizia. It's in Libya, where the temperature records from weather stations revealed it hit 57.8 degrees Celsius. So, my God, think about that. On September 30, 1922. And which is the coldest spot? Of course, it should be in Antarctica, right? But the temperature is unbelievable. Winter temperature there can drop below minus 100 degree Fahrenheit, or say some minus 73 degrees Celsius. But the lowest temperature ever recorded on Earth came from Russia's Vostok station in Antarctica, where a record show the air plunged a bone-chilling temperature of minus 89.2 degrees Celsius. Yeah. So this is the end of the particular Earth slide. Then we will move to the Mars slide. I'll share the screen. So Mars, it is the fourth planet from the Sun after Mercury, Venus, and Earth. And it is also referred to as a red planet. The rocks and soil have a red or pink hue due to iron oxide. Iron oxide is rust. You know that, right? And it's because of this iron oxide content, it looks red in color. See, this is the NASA Hubble's telescope picture for Mars. It is a view that provides the most detailed and complete global coverage of the red planet Mars ever seen from Earth. This picture was taken on February 25th, 1995, when Mars was at a distance of 65 million miles.
Mom, is that blue hue clouds?
Yes, it is. It has a very thin atmosphere,
Okay.
and it's a polar region. Now, Mars has a rocky, dry terrain with huge volcanoes and deep valleys. and the atmosphere here is much thinner than Earth's and is comprised primarily of carbon dioxide and nitrogen. Also, its gravity is about one third of our own. This is the largest volcano in the solar system. Its name is Olympus Mons. It's not active now, but once it was active. And maybe in the coming period, in the future, it may become active. Now it is dead. The altitude of Olympus Mons is three times the altitude of largest peak on Earth, that is Mount Everest. Then look at the size of imagine the size of Olympus Mons. Now this is a very important, feature on Mars. This is called Valles Marineris. So Valles Marineris, or also it's called Mariner Valley, is a vast canyon system that runs along the Martian equator. It is 2,500 miles long and reach up to 4 miles, depths of 4 miles. Now, yeah, about the dust storm. We have seen the movie Martian in the beginning of the movie when the actor, when the astronauts are landed on the Mars, when they are coming back to the spaceship or coming back to Earth, then this global dust storm occurs, right? It's not like, in deserts, it happens sometimes, but it is a local phenomena. But for Mars, it's not a local phenomena like that of Earth. It's a global phenomena. Look at this. The whole Mars has been covered with dust. Now, like Earth, Mars has seasonal changes, but the seasons last much longer. In winter, Mars' polar ice cap can reach down to 45 degrees latitude and then rapidly shrink during spring. Dust storms are seasonal, also as witnessed in this Hubble image. Now there are some of the characteristics of Mars and Earth. Mars is 141.6 million miles away from the Sun. It has a diameter of 4,222 miles, and then length of year is 687 Earth days, which is double, almost double the Earth's year. But length of day is similar. Length of day in Mars is 24 hours, 36 minutes, which is slightly more than that of Earth. Then gravity is actually less because the mass is less. Earth has 2.66 times gravity than that of Mars, or in vice versa, we can say Mars has 0.375 uh, than that of Earth. The average temperature of Mars is minus 81 degrees Fahrenheit, and it can change from minus 127 to 17 degrees. Yes, it has two moons. Now, the name of Mars. The planet was named after Mars, who is the Roman god of war. Mars was one of the most worshipped and revered god in ancient Rome. In ancient times, it was, war. War was their thing. They used to do it all the time, right? So that time, the Lord of War was like a Superman, superhero. So God Mars held a special place in the Roman pantheon, not only for his patronly influence, but because of the importance of military achievement in the Republic and the Roman Empire. Now, before the space exploration, we didn't know Mars much, right? So, when we looked through the telescopes, we saw channels. We saw arranged channels, and also we thought that like they are water canals and irrigation canals, etc. So there was this common misconception that there was life, that too intelligent life on Mars. Italian astronomer Giovanni Schiaparelli thought he saw straight lines crisscrossing its surface, and this led to the popular belief that irrigation canals on the planet had been constructed by intelligent beings. Now, in July of 1965, Mariner 4 transmitted 22 close-up pictures of Mars, and all that was revealed was a surface containing many craters and naturally occurring canals, but no evidence of artificial canals or flowing water. Here you can see there was two landers Viking in the Viking mission of September and July and September 1976. Landers 1 and 2. Viking Lander 1 and 2. The three biology experiments aboard the landers discovered unexpected and enigmatic chemical activity in the Martian soil, but it provided no clear evidence of the presence of living microorganisms in the soil near the landing sites. So the search was over. There is no any life left on Mars. But the interesting thing is, according to scientists, Mars is self-sterilizing, which means there is this combination of solar ultraviolet rays, that is UV radiation, that saturates the surface. You know that UV radiation can sterilize things, right? Sterilizing means getting rid of all the microorganisms. So naturally, Martian atmosphere has this ability. When this solar ultraviolet rays saturate the surface, there is extreme dryness of the soil and oxidizing nature of the soil chemistry prevent the formation of living organism in the Martian soil. Now the question of life on Mars at some times in the distant past remains open. So it is believed that maybe millions or billions years ago, there must have been life on Mars, but not now. Now there is this rover. A number of rovers has been sent to Mars, and first of its kind is the Pathfinder, Pathfinder. It was the first instrumental lander and robotic rover to study the surface of Mars. Finding from the investigations carried out by scientific instruments on both lander and rover suggests that Mars was at one time in its past warm and wet, with water existing in its liquid state and a thicker atmosphere. But now the atmosphere is not thicker and it is sterilized by UV radiation. Now there is another set of rovers, Spirit and Opportunity. They used to study a lot of things in the surface of Mars and provided a lot of data. Till now, they are useful. This is an important feature. In 2005 March, Spirit studied rocks in the Paso Robles area that have high sulfur content. And much of this high sulfur is contained in the hydrated iron sulfate mineral, but that can only have formed if there was presence of liquid water was there. So this is one of the reason why we we doubt that whether there was water on the surface of the Mars one day. Now there is this another rover opportunity spectrometer and microscopic imager found that rocks near the lowest slopes of endurance created were affected by water both before and after the crater formed. Now, the future exploration of Mars. Yeah, many Martian missions are about to come, and we envision that we will one day set living bubble habitats on Mars, and there will be people living there. Yeah, all these are future plans. So that's our Mars slide. And next we'll go to our comet slide. Please. And after that, you can ask your doubts, okay?
Okay, ma'am.
Yeah. Comets, asteroids, and meteors. So the question is, can you identify these celestial objects? Of course, right? The first one is an asteroid. The second one is a comet. Sorry. And the third one is a shooting star or a meteor. So sometimes we have confused about these three things, right? So is there any difference between asteroid, comet, and meteor? Of course, there are. Let's have a look at the slide to study more about it. Comets and asteroids. Comets, both of them, comets and asteroids, If it is near to the Earth, we can of course call it near Earth orbit objects. But there is a fundamental difference between comets and asteroids. The first thing is comets are icy body. It is mostly made of ice, while asteroids are a rocky fragment. They are made of rock. So that is the basic difference between comets and asteroid. When this smaller asteroid it comes to the Earth's atmosphere, then we call it meteor or shooting star. So comets and asteroids are remnants from the formation of our solar system some 4.6 billion years ago. Comparison of some characteristics of comets and asteroids. Here in this table, you can see a comparison. And let's say the origin of comet. Mostly, these comets are originated from Kuiper belt or Oort cloud. The Kuiper belt is the trans-Neptunian belt, which means it is after the Neptune. Okay, it's just like asteroid belt, but with more asteroids and comets present inside. So they are called the Kuiper belt, and after the Kuiper belt, there is this Oort cloud. It's a bubble-like structure. Maybe it's in the figure. I'll show you. Oh yeah, this is the Kuiper belt after Neptune. We do have a Kuiper belt, and this whole cloud, which bubbles the whole solar system. That's called Oort cloud. So mostly this comets are from there, while asteroids, most of them that we see from Earth is from main asteroid belt. Now, shape and size, they are actually regular. Both of them, comets and asteroid, they may not be having a particular shape. It's varying for different comets and asteroids. Now, the size range of diameter for a comet's nucleus, it can be from 1 to 10 kilometers wide, while asteroids, it is 1 to 100 plus um, kilometers wide. So from this, we understand that comets are, asteroid belts are larger than that of comets. Now, about chemical composition, mostly comet contains ice, frozen gases like ammonia, methane, and carbon dioxide, and other organic compounds such as carbon containing compounds. So asteroid, they mostly contain silicates, that is rock, right? And iron and nickel. Olivine and pyroxene are different minerals present in silicate. So orbit is for asteroid, it's mostly circular, and for comet, it is elliptical. It's highly elliptical for comet. This long-term comets are coming from Oort cloud. Their orbit is highly elliptical. Now the comets and asteroids, yeah, they have irregular shapes and have varied sizes. Both reflect light from the sun at varying amounts depending on the size and composition. Now, silicates are minerals which contain the minerals that like elements, silicon, oxygen, and at least one metal which is responsible for the comets and asteroids to be able to reflect light. The long period comets come from Oort cloud, while short period comets come from Kuiper belt. So if there is a question like from the short period comets are coming from, answer is Kuiper belt. Every one of you have heard about Halley's comet, right? So the most famous comet of the 20th century is this particular one, and it's also known as the short period comet. It takes some 75 to 79 years for comet Halley to orbit the sun. The long period comets can take up to some 200 to 100 millions of years to complete their orbit around sun. But asteroids originate from the main asteroid belt between Mars and Jupiter. Actually, this belt is theorized by scientists to be the remnant of the planet that did not completely form. And the orbit of the asteroid is more rounded and less elliptical than the orbit of a comet. And the asteroid series was discovered in 1801 Actually, it's now called the dwarf planet, right? By Giuseppe Piazzi, which is the largest asteroid in the asteroid belt. It is also termed as a dwarf planet. It is made of rocks, ice, carbon, silica, and different metals. It's also called planetoids or minor planets. But comets, come from regions of space very far away from the heat and radiation of the sun. That's why they are fully made of ice. Comets are made of frozen matter, while asteroids are rocky fragments, just like we studied. So this is a typical example of comet. Comet has a dust tail and a gas ion tail. This is a nucleus. Nucleus will be really small, some 10 kilometers maybe, but its tails are longer. Here you can see if these comets are not near to sun, they are dark and invisible. And when a comet is near to sun, it becomes visible because the tails are formed. When a comet is approaching the sun, its iron tail is behind it, but when it is moving away from the sun, iron tail goes ahead of it, which means each time, like maybe a comet is approaching or leaving the sun, the tail will be always away from the sun. Why the tail is produced? It's by the interaction of solar wind with the particles in the surface of this dirty ice comet, and it will be volatile and continuously giving off. That's why even though the comet is going away from the sun, then also the tail will be away from the sun. So this is the position of asteroid belt. And here in Jupiter's orbit, you can see two set of asteroids, right? They're called the Trojan asteroids. They are not part of asteroid belt, but are in Jupiter's orbit due to the gravitational pull of this one, and it will be revolving together.
This, so that
Yes.
means all these asteroids will be crashing on Jupiter's surface, right?
Yeah, sometimes, but not now. Yes, now the difference between meteoroid, meteor, and meteorite. A meteoroid usually all burns up when it enters the Earth's atmosphere, right? Because it has to travel a lot of maybe say 100 to 200 kilometers, and if they are not big enough to reach the Earth after all these burning up process, it will of course burn up. But there are some meteors which are large enough and the remnant can reach the surface of Earth. When that kind of one, when after reaching the surface of Earth, if we found it, we call it meteorite. So a meteoroid is an asteroid when in space, and when it in the atmosphere, call it meteor, and meteorite when it is um, hit on Earth. We have studied about it yesterday. Now, meteor shower. Meteor shower is a light phenomenon caused by fragments left by a comet or an asteroid as they orbit the sun. Then the Earth orbit, when the Earth orbits the sun and passes through that comet fragments, a streak of light is produced. That's how this meteor shower is produced. So maybe some fragments are already been in the space in the region where we are orbiting sun, and when Earth passes through that region, we'll get this shower. Now there are different types of meteorites. One is stony meteorite. It's the most common type of meteorite and generally composed of approximately 75 to 90 percentage of silicon based materials or minerals, 10 to 25 percentage of nickel iron alloy, and trace amounts of iron sulfide. Now there is stony iron meteorite. Stony iron meteorite contains approximately even amount of silicates and nickel iron alloy. Alloy is the combination of metals, right? Maybe you have studied it. And then now there is iron meteorite. Most iron meteorite likely originated in the course of large asteroid and are composed almost entirely of nickel iron alloy, which is also a primary component of the Earth's core. Yes. So now we have finished the session. Good night. Thank you.
Good night. Thank you, ma'am. Good night.